Hello and welcome back. Today we're going to continue with limits. We're going to see limit properties. If the limit when x approaches to a of f of x is equals to L, any number, and limit when x approaches to a of g of x is equals to m, you see we are approaching to the same number in x, and c is any constant. Then we have the following limit properties. The limit of a constant is the constant. We read this limit, the limit when x approaches to a of c is equals to c. How can we understand this? Here I have the graph of y is equals to 4. Then, as you can see, the graph of this function is a constant. Always going to be 4. It doesn't matter which value I'm approaching, x, minus 5, minus 4, minus 3, minus 2. In y, the value that I'm going to approach is equals to 4. That's why the limit when x approaches to, let's do an example. Let's say we are approaching in x in 3, or negative 3, of f of x, of 4 in this case, is going to be 4. And it will be true for any value of x. That's why we can say the limit when x approaches to 8 of a constant is going to be the constant. Let's continue with the second property. The limit of a power is the power of that limit, and the limit of a root is the root of that limit, assuming n is a positive integer. Remember, we need to work with positive numbers. Let's say we want to find the limit when x approaches to 2 of x plus 2 is going to be f of x raised to the second power. Well, using the limit property, I can write it this way. First of all, I can find the limit when x approaches to 2 of x plus 2, and all of this is going to be raised to the second power. It's going to be easier because the only thing that I need to do is plug in the 2 instead of the x to evaluate my limit, and I will know which value I'm approaching to in y is 2 plus 2, and all of this is going to be to the second power, which is 4 to the second power equals to 16. Now let's see what happens if we want to find the limit when x approaches to 4 of the cubic root of 6x plus 3. Well, again, using the property of the limit, we can write it this way. We can say is the cubic root of the limit when x approaches to 4 of 6x plus 3. Well, again, we can evaluate when x approaches to 4. Then instead of x, we're going to write the number 4. We continue with the cubic root, and I have 6 times 4 plus 3. And this is equals to the cubic root of 6 times 4 is 24 plus 3 is 27. And cubic root of 27 is 3. Let's continue with this next property. The limit of a sum or a difference is the sum or a difference of the limits. Okay, Then the limit when x approaches to a of f of x more or less g of x is equals to the limit when x approaches to a of f of x, more or less the limit when x approaches to a of g of x. That means the answer of the first limit plus or subtraction the answer of the second limit. How can we understand this? Let's say h of x is equals to f of x plus g of x. And f of x is 2x and g of x is 3. Then we can write h of x as 2x plus 3. Okay, this is going to be g of x, f of x plus g of x. Now, how can we find the limit? Well, it's the same if I take the limit of 2x. I'm just going to take the limit of f of x when x approaches to a. Let's say we want to find the limit when x approaches to 4. Then it's going to be the limit when x approaches to a, to 4 in this case, of f of x is 2x. Plus, because we're adding, if we're subtracting here, we're going to be subtracting here. The limit when x approaches to 4 of g of x. And how much is g of x? 3. As we say, this is going to be the limit when x approaches to 4 To know the value of the limit, I just need to plug in, instead of the x, I'm going to plug in the 4. And the limit when x approaches to 4 of 2x is going to be 2 times 4. And as we saw in the first property, the limit when x approaches to 4 of a constant, okay, when x approaches to a of any constant is going to be the constant. That means this is 3. Therefore, my final answer is going to be a plus 3, which is 11. Then we can say the limit when x approaches to a, in this case a is 4, of 2x plus 3 is equals to 11. The next property is about product. The limit when x approaches to a of f of x times g of x is equals to the limit of f of x when x approaches to a times the limit when x approaches to a of g of x, then is equals to L times L. Okay, let's see if we want to find the limit when x approaches to 2 of x cubed. Another way I can write this is the limit when x approaches to 2 of x times the limit when x approaches to 2 of x times the limit when x approaches to 2 of x. How much is going to be? Well, I'm just going to plug in. Because I'm just plugging the value here, the limit when x approaches to 2 of x is going to be 2 times, is the same answer, 2, and is the same answer, is 2. 2 times 2, 4, 4 times 2, 8. Then my final answer is the limit when x approaches to 2 of x cubed is equals to 8. We will continue with the second part of the property of limits in the next video. See you!